Good day, everyone! We are your math teachers for today, and we're gonna tackle about derivatives! Let's start!
Before we have an example, let's have a recap of the derivative rules. So our first rule is the constant rule. If you have a function equal to k, then f prime of x, or the derivative of f of x, is equal to 0. So any constant's derivative is equal to 0. Second rule is the constant multiple rule. If you have a function equal to k times f of x, then f prime of x is equal to k, or the constant, times the derivative of the function f of x. Our third rule is the power rule. If you have a function equal to x raised to n, then f prime of x is equal to n times x raised to n minus 1. So we'll just bring down the exponent here and multiply it to the variable raised to n, or your exponent, minus 1. Our fourth rule is sum and difference rule. If you have a function equal to f of x plus g of x, then f prime of x is equal to f prime of x plus g prime of x. So we just simply get the derivative of each function. Next rule is the product rule. If you have a function equal to f of x times g of x, then f prime of x is equal to u dv plus v du, where u is equal to the first function and v is equal to the second function. We'll just label this first function equal to u and the second function as v, and then u times the derivative of v plus v times the derivative of u. So that is your first 5 rules, and let us show you some examples that applies this kind of rules.
For this problem, f of f is equal to 4x raised to 5 times 12x squared plus 15x plus 3. So, ang una natin gagamitin is product rule. U as 4x raised to 5, v is equal to 12x squared plus 15x plus 3. Una muna, u 4x to the fifth power times the derivative of 12x squared plus 15x plus 3. The derivative of 12x squared is 24x. The derivative of 15x is 15. Then the derivative of 3 is 0. Plus v 12x squared plus 15x plus 3 multiplied to the derivative of the u. 4 times 5x to the fourth power, which is 20x to the fourth power. Then after this, we just simplify these two terms. 96 plus 6x to the fifth power plus 240x to the sixth power plus 300x to the fifth power plus 60x to the fourth power. 96 plus 240 is 336x to the sixth power plus 60 plus 300 to the fifth power is 360x to the fifth power plus 60x to the fourth power came from 60x to the fourth power.
So for our next 3 rules, we have quotient, exponential, and logarithmic rule. First, let's go to quotient rule. If we have a function is equal to f of x over g of x, first we'll label this as high, and we'll label this as low. Then f prime of x is equal to low times the derivative of high minus high times the derivative of low over low squared. Next is the exponential rule. We have 2 conditions here. Our first condition is if f of x is equal to a raised to x, where a is a constant and x is a variable, or exponent is a variable, then f prime of x is equal to a raised to x times ln of a. The second condition is if f of x is equal to e raised to x, then f prime of x is e raised to x. So we just simply copy. The next rule is the logarithmic rule. We also have 2 conditions here. If f of x is equal to ln of x, our f prime of x is equal to 1 over the value of x here. The second condition is if f of x is equal to log of x base b, then f prime of x is equal to ln times your b here over x. So let us give you an example.
Ang next na problem is f of x is equals to e raised to x times cosecant x. Nakikita naman natin na may dalawang function, so gagamit tayo ng product rule. Yung first function, ililabel natin siya as u, and the second function, ililabel natin siya as b. So yung next step is f prime x is equals to e raised to x na yung u derivative of v is ex times negative cosecant times cotangent x. And makikita natin to sa trigonometric rule plus cosecant x times e raised to x na makikita natin sa exponential rule over next step is simplify. So ito na yung sagot is f prime x is equals to e raised to x times negative cosecant times cotangent x plus e raised to x times cosecant x.
So now we're going to discuss about the next two rules of derivatives. So, the trigonometric rule. If you have a function sine of x, then its derivative is equal to cosine of x. Then, the derivative of cosine x is equal to negative sine x. The derivative of tangent x is equal to secant squared x. The derivative of cotangent x is equal to negative cosecant squared x. The derivative of secant x is equal to secant x times tangent x. And lastly, the derivative of cosecant x is equal to negative cosecant x times cotangent x. So this is your trigonometric rule, and we have to memorize this for us to be able our examples later on. The next rule is the inverse trigonometric rule. So we will memorize this also. So the first is the inverse of sine x. Its derivative is 1 over square root of 1 minus x squared. The inverse of cosine x its derivative is negative 1 over square root of 1 minus x squared. The derivative of inverse of tangent x is equal to 1 over x squared plus 1. The derivative of inverse of cotangent x is equal to negative 1 over x squared plus 1. The derivative of inverse of cosecant x is equal to negative 1 over x squared times square root of x squared minus 1. And lastly, the derivative of inverse of secant x is equal to 1 over x times square root of x squared minus 1. So we'll just have to memorize this. For our last rule is the chain rule. If we have a function is equal to f of g of x, then f prime of x is equal to the derivative of f of g of x times the derivative of g of x. This just simply means that if we have a function inside the function, we just have to multiply the derivative of the outer function into the inner function. And then your solution goes on. So let us give you an example that applies these rules. So now we're going to tackle an example which applies the rule of inverse trigonometric function. So let's start. We can see that this function is a quotient. So we're going to use quotient rule, which is low d high minus high d low over low squared. So let me show you how I did it. So copy low times the derivative of high, which is this one. So the derivative of this one, tan inverse of tangent x, as stated from the inverse trigonometric rule, is 1 over x squared plus 1. So we'll just write it here. So x squared times 1 over x squared plus 1 is the low d high minus high d low. So copy high, the inverse of tan x times the derivative of low. The derivative of low is 2x because x squared will apply power rule. So bring down 2, then 2 times x raised to n minus 1, where n is your exponent. So 2 minus 1 is 1. Any number raised to 1 is equal to itself, so 2x over log squared. So x squared is equal to x raised to 4. So now we'll just simplify our answer. So x squared times 1 over x squared plus 1 is equal to x squared over x squared plus 1 minus tan inverse of tan x times 2x is just simply 2x times tan inverse of tan x over x raised to 4. So this is your final answer.
Hi, I'm Miguel Balayan, and today I'll be discussing about the higher order derivative. So higher order derivative is simply getting the derivative of a derivative.
Okay, so we're gonna use this function for the example. So y is equals to 4x cubed plus 12x squared plus 7x. So let's find its second derivative. So the first derivative, the first step that we're gonna do is the sum and difference rule, since we can see the addition sign here. So sum and difference rule means that we're just gonna find the derivative of each function. So for the first function, 4x cubed, we're gonna use the constant multiple rule. So we're just gonna copy 4, and then for x cubed, we're gonna use the power rule. So let the exponent be n, so we're gonna move it beside x, and then n minus 1. So move it here, so it will be 3x, and then n minus 1, 3 minus 1 will be 2, so 3x squared. Plus, so constant multiple, copy, and then power rule. 2, and then 2 minus 1, 2x. Plus 7, copy, and then move 1, 1 minus 1, 0, so 1. And then we're gonna simplify it. So 4 times 3 will be 12x squared plus 12 times 2, 24x plus 7 times 1, 7. So now we're done with the first derivative. We're gonna find the derivative of it. So the derivative of 12x squared is, again, constant multiple. So copy 12, and then the power rule. So move n here, 2, and then n minus 1, so 2x. Plus 24, copy, and then power rule, 1. And lastly, here, since it's a constant, we're going to use the constant rule. So automatically, it will be 0. And lastly, we will simplify this function, and we will come up with the answer. 12 times 2x will be equals to 24x plus 24.
Hi, my name is Bryant Maliwat, and today I'm going to discuss about implicit differentiation. So let's start. So now for our last example, we're going to tackle about the implicit differentiation. So in implicit differentiation, the only difference of this kind of examples from our past examples is that we're going to add y prime every time we differentiate y variable here. So let me give you an example. The y is equal to ln of x squared plus y squared. Our first step is get the variables of each function. So here, y prime equals the derivative of this is the whole function is 1 over x squared plus y squared. Since we have a function inside the function, we'll use chain rule. So multiply the inner function, the outside function to the inner function. So this is the derivative of our outside function, and the derivative of our inner function is this one. So the next thing we're going to do is just simplify our answer for us to be able to isolate y prime or get the value of y prime. So I multiplied these two, so I come up with this answer, 2x plus 2y y prime over x squared plus y squared. And then the next thing I did was I cross multiplied both sides of the equation, and I come up to this answer, x squared times y prime plus y squared times y prime is equal to 2x plus 2y y prime. And then I put those values with y prime on the left, and on the right are those who don't have y prime. So I come up to this answer, and x squared y prime plus y squared y prime minus 2y y prime is equal to 2x. And then I factored out y prime for me to be able to be able to isolate y prime, then y prime times x squared plus y squared minus 2y is equal to 2x. Then I divide both sides by this x squared plus y squared minus 2y to keep y prime alone. So, cancel, and then our y prime value is equal to 2x over x squared plus y squared minus 2y. That is your answer.
And I'm Miguel Balayan. And I'm Bryant Maliwat. That's it for today. We hope that you learned something today. And don't forget